So right now what we're going to look at is solving formulas for a given variable. This is useful when, let's say you have a series of things that you have to solve, where you have to solve the same type of equation overall. But let's say if I was figuring out volume, let's say I knew the volume and I knew the width and I knew the length all the time. The only thing that I needed that was changing was the height, and I didn't know what it was. So if all you're trying to figure out is the height, it makes sense to move all the variables that you know to one side so that you're solving for the h. So instead of solving for v every time, we already have v. So let's maybe solve for h. Scenarios like this come up all the time, and so what you're going to do is basically you're going to realize that while they're all letters, while we have 4 variables, it's still just our basic operations between them, and we can always treat them as if they were specific numbers. Here I want to get rid of the w and the l because I want to solve for h. This one will be nice and easy. It's one step. You could, I suppose, dissect it into 2. I'm going to divide by the length and the width. So if I don't want the length and the width by the h, I divide by them. This is our division property, right? Now you have h by itself, and that equals the volume divided by length times width. It's just that simple. Remembering that whenever I say solve for x in an equation, I mean I want to isolate the x. So if I look at a formula and I say solve for h, or any variable, you want to isolate whatever variable that is. You know it's isolated when there's no numbers, no squares, and no other variables on that side. This one was one step. Over here we have the Pythagorean theorem. Let's say we want to solve for b. Let's say I was always given my hypotenuse in one leg. Well, it doesn't make sense to do the same operations over and over again with your numbers. So let's get b by itself so we don't have to ever, so we already have that isolated and we can just plug in our numbers, our leg and our hypotenuse, and find some different things. First step here, let's undo our addition. Subtract a squared from both sides. This is your subtraction property. That's going to leave you with b squared equals c squared minus a squared. Your next step, when you look at b squared, you know there's a way to undo a square. It's called a square root. So you're going to square root both sides. You're going to be left with b equals the square root of c squared minus a squared. Now one note for you guys. When I square root something, typically it could be a plus or minus. This cannot be plus or minus if you're talking about a triangle, because a length can never be negative. So you don't have to put the plus or minus in front in this particular case, because you are talking about length and you know only the positive answer is going to work for you. And that is a couple basic examples of solving different formulas for a given variable.